So this says finding a composition of functions. They're asking us to do kind of what we did in the last video. So we're going to find f of g of x, and then we're going to find g of f of x. Okay, so to make this a little bit easier, I think I'll color code it. So I'll do this one in orange, so hopefully you can see the difference. Okay, so we want to find f of g of x. Or f of, now do we know what g of x is? We do, it's 3 minus x. So then we're going to take that 3 minus x and we're going to put it in the other function, the f function, because we're going to find f of 3 minus x. So that's going to look like 2 times 3 minus x plus 1. We're going to simplify this up. So distribute 6 minus 2x plus 1, or 7 minus 2x. Okay, so that would be the f of g of x, right there. All right, now we're going to do the orange part, and we're going to find g of f of x, or g of 2x plus 1. So now what we have to do is we have to take the 2x plus 1 and we have to put it in the other function. So it's going to look like 3 minus, don't forget the parentheses here, 2x plus 1. Then we're going to distribute and we're going to simplify. And that would be g of f of x. Now, the question also says determine whether the composition of the functions is commutative. So when you add two functions together, that's commutative. Addition's commutative. Multiplication's commutative. Is composition commutative? So did we get the same thing? When we took f of g of x over here, did we get the same thing when we took g of f of x? And no, they're not the same thing. So no, composition is not commutative. Now you might say, well, maybe it would work, with the other functions. It might, but to prove something's true, it has to be true in all cases. And we just found a case where they don't come out the same, so we can say that composition is not commutative. Okay?